Today I'm going to talk about an only one step ahead guide for machine learning projects. It's only one step ahead because I'm a noob. I have only 2 years of data science experience. I don't have much of software development or any type of that. And if you went to Michael Mann's talk this morning, he said something about, oh, we have a mathematician who's a horrible programmer. That's me. That's like exactly like me, horrible programmer. So you will hear a lot about my pain. This is my title for the talk, but you can think of it also known as why I suck in my machine learning projects. And I want to help you in a way that in 15 minutes, I will save you 15% or more on your project completion time. Don't step on the same mistakes that I made, all right? And we ready to start? Turn it on again. So the story usually goes like this. You have a business, here's some business owner about some problem, and they have some data. They want to say, oh, we have a lot of data. This is the age of big data. We got a lot of data. We can do a lot of things. So they come to you and say, hey, what can I do with my data? I have a business problem I want to solve. What can I do about it? And then you're like, this is 21st century. How do we solve a problem? Let me Google it. So you put in the search bar. I have data, XYZ. I want to solve problem ZYX. You put in, and out comes machine learning. Because it solves everything. Is that true? we have some thoughts about that, right? I would say machine learning is a powerful tool that we don't have a few years back. And it does solve a lot of problems. It's great. And you can start thinking about, oh, I want to use machine learning to solve my business problem. Or just flat out buzzword-driven development, that's fine too. So you have some, oh, okay, I have some idea what my project is going to be like. Let's start do it. Let's pull in the data. Let's get some algorithm going and make my predictions. But the reality feels like an impossible journey. It feels like I'm taking this ring to the volcano of Mordor by myself, and nobody's trying to help me. I had to fight all the bad boys. It's just impossible. What's wrong? What happens to that happy land that all the tutorials, online courses, blog posts trying to paint? Where is that? And like I said, I'm a noob, so I was a firm believer. But after a while, I became a little skeptical. I still think there's great potential. I'm not trying to turn you into skeptical, but I have a lot of thoughts, and I want to share with you. And because of a lot of the people here have way more experience in software engineering, I think you can help everyone solve this problem. In particular, start with helping your own company. If you're interested in this talk, help your team solve this problem. What are some things around machine learning that make people ineffective? What are some things that tutorials don't talk about? What are some real challenges that you will face no matter what kind of industry you're in? I started out in academia, and I worked in a local team, sports team in Florida, so I'm really happy to be here, back to Florida. And then now I'm in North Carolina doing retail. There are some patterns that I have seen I think are applies to every industry or most of the problem you're trying to solve. But it's by no means that best practice. I'm not trying to sell a best practice, but just my own thoughts. And I'll open the discussion. That's why I put my Twitter handle there. Feel free to talk to me afterwards and have some discussions because we are all having our own evolving thoughts. And we can all make ourselves more effective. So feel free, if you have better thoughts than what I presented here, feel free to let me know on Twitter, on social media, whatever. But let's get started. So what is machine learning? When I think of machine learning, I think of making predictions. Or rather, making individual predictions. As in, I have a bunch of data points, I want to be able to make predictions or know what the outcome is based on the data I have for individual data points. You can build a lot of things around machine learning, but I think that it comes down to making individual predictions. One thing, just like what Michael Mann has referred to in his talk, was when I think about like, oh, so what we can do, if I want to make individual predictions, where do I find things that I can use machine learning for? One thing we humans are really good at is making simple rules. This is like a chart that I see a lot in our business meetings. People really, for some reason, the IT department, whatever, really likes workflow charts or a lot of boxes and like yes and no's, what happens. So we're really good at simple charts like that. If you have 5, 6 workflows, it's easy to code, it's easy to understand, and that's how most humans operate anyway. We say, oh, I have this, I have some criteria, do I go right or do I turn left? That's easy. But in a real business, what happens a lot of times is as time grows, the chart also grows. And when you sit in a meeting like that where you see a flow chart like that, I don't know about you, but for me, I'll just be like, please don't put me on a recurring meeting with you. Because I don't understand what you're trying to say. But I believe that there are a lot of software systems out there that have become like this just because of the complex business logic around it. Or you have a software that's trying to solve everything. It just inevitably become like that. So it's just life. We have complex systems. But humans are really bad at complex systems. If you want to improve this system, you want to make a case, oh, I want to add another box to it because of X, Y, Z, it's really hard to know the good or the bad around that type of decision. So one thing machine learning is good is doing something about that type of system. One example that I kind of like is financial crime. Back in the day, I came from Taiwan, by the way, so I have very Hollywood-esque understanding of America. Back in the day, I guess in the 60s, I would imagine, oh, how people commit financial crimes is go into a bank, grab a bag of money, and you have some deputy with a cowboy hat just chasing that bad boy. And a lot of good car chases or whatever happened afterwards. That's back then. It's simple. It's just like going to a bank, rob the bank, and then that's how you solve the problem, I guess. But these days, financial crime has become increasingly complex and sophisticated, especially when you talk about international crime. There are a lot of people trying to scam everyone in all sorts of ways. How do you catch all of them? It's impossible to come up with a rule or just a rule-based system to catch all of them. So what the bank usually do is if they want to catch some fraud, they will build a bot. Oops. They will build a bot for it. And that bot, a lot of time, start out with a rule-based system. After they have some success with it, they replace it with machine learning. Because you want to make individual predictions. One prediction at a time, one client at a time, one customer at a time. You want to know whether this person is bad or not. So that's a use case for machine learning, is to reduce a complex software system that has a lot of rules that develop over a long time. Maybe we can do something about it when we can't really justify adding another rule to it. Or how would that perform? How would that impact our system? So that's what machine learning is good at. But it's not for every single thing. Sometimes what you might want to ask before you start applying machine learning, not sometimes, but every time before your business owner is trying to sell you using machine learning to implement machine learning to solve the problem, you want to ask, what does it do? What do you want this piece of software to do. Maybe the goal wasn't to make individual predictions. Maybe what they want to know is some rolled-up statistics of the data, because people don't really need machine learning to act. The government don't have to tell people how high or like making individual predictions of employment. They just give you a roll-up number about employment, and people will start acting according to the stock market will anyway. So one thing a question that it's always good to ask is, do I really need machine learning, or is my goal something else? In that case, a lot of people will say we want insight and we are not looking for prediction. For that type of problem, maybe statistics can help you. Maybe how you can help the business is building some reports, automate some reports for your team. Or maybe you can run some experiment in the field. Those are great ways to help you understand the data. And machine learning are really bad for these type of inquiries, because a good machine learning or a good predictive system usually has some complexity associated with it. And the more complex your system is, the harder it is for you to extract the insights. So ask those questions before we jump into machine learning. Will save you a lot of time and a lot of headaches that comes with it. Another question before you start machine learning is ask, where is my data? By where is my data, I'm referring to those creepy Excel spreadsheets that lives in one of your analyst's laptop or some business owner's laptop. People love Excel spreadsheets, but they don't let you know, or some Access database or whatever. It's just like nobody ever knows that kind of thing exists. And I have an experience where I was working on a project. I tried to find this piece of data. I couldn't find it. I spent 2 weeks on trying to find that piece of data. I didn't know. I thought, okay, we don't have it. That was 6 months ago. 2 weeks ago, I learned that, yes, we do have it. And it's really hard to find sometimes if you have a big company, because there are a lot of tribal knowledge around this quote data lake. So maybe what you want is, when you have a lake, people start building their tribes around it. Just backpack and start interviewing people in those tribes and see how they can help you with your problem. And a lot of time people are willing to share. They're willing to let you know what they have thought of the problem, and they're willing to share with you their data. So go ahead and build some relationships and find out where is the data, because it will save you a lot of time when you have the data beforehand, instead of trying to find out what you think is the right data is not. That also happened to me before. Wasted a month. So now we know we want to do machine learning. How do I even start a project? I don't know how, I'm not gonna say, oh, by the way, I'm not gonna show you any hard, complex algorithm here, because that's something we can look up ourselves. There are two things I want to address in this section. Is question that I heard most from people who ask me, or just in general, or the question I had when I first started. One, if I have a machine learning project, I want to make a prediction. How do I evaluate my model? How do I set up the process to evaluate my model? Two, what kind of model should I use? Those are, in my opinion, the universal question around machine learning. And hopefully I can give you some of my thoughts. But before you start doing that, once we have the data, the most essential step wasn't asking those two questions, but build a strong data pipeline. By a strong data pipeline, what I meant was, when you start working on a model, we are not just building, most of the time you're not just building the model for fun. So it won't be just a one .csv file that sits on your computer and then just iterate over that one CSV file. Most likely you will get 100 CSV file that comes, like just as the project goes on and people start throwing an idea at you, you go fetch more data. And then also you never want to predict the past there's really not much value in predicting the past. So you'll always also have some future data that comes in. And this is one thing that has kind of like hit me really hard was I am not a good software engineer, and I don't know how to automate this data pull. Or at least I didn't know. Another thing that has come to my mind was I didn't know how to test this data pipeline. What I mean by testing was, an example I can give you was, let's say I have a project. I work on it for 3 months. Okay, I hit my whatever metric I'm trying to hit. I'm 50% there. This is great. And then one day, I have my data come in every day. And one day I discover the vendor made some changes to our data. And this one column that is essential to my model, which will give me 10%, accounts for 10% of the accuracy, whatever, starts spitting out no values. What do I do? Hey, that's really bad, but there are some things you can engineer around it and maybe write some tests to discover that. Actually, I didn't discover it in the first place. I was just like, why my model has become worse? What's going on? And then I dig in, I found that. If you have an automated test, maybe I don't have to spend 3 days trying to figure out what was wrong. So if you have a strong data pipeline, ideally you have some way to pragmatically get the data, however many data that you want, and distribute it to whoever's on your team, and you don't have to copy paste all the files. There are some ways that software engineers are really great at. I'm really bad at. So that's just food for thought. But it's a healthy data pipeline or healthy data engineering, in my opinion, is the most crucial to the success of a machine learning project. And machine learning in general, sometimes you feel it's overhyped, and data engineering is underhyped. But data engineering is really, really important. So once you go out and interview those business owners, you know where the data is. Try to see if you can find a way to get the data. If there's new data there, sometimes it will nobody has only one Excel spreadsheet. They have a final version 2, right? So how can I get that final version 2 to myself? Put it as that's more something that you can think about and probably differs in every company. So now we have the data, we want to start the project. The first thing is, how do I define my metric? I think when I started, I also look into Kaggle and stuff like that. And if you talk about metric, like how do you evaluate your machine learning model, everyone has their own opinion. Not just opinion on the mathematics of the metric, but also what kind of business logic should I apply to my metric. For example, if I'm running a restaurant, it makes sense to optimize my revenue. Does tip count as revenue? I don't know. Maybe yes, maybe no. If we have a discount item, or I don't know, we're doing something about Uber Eats, should I optimize on that as well? There are a lot of things when you start talking to your business owner, what kind of metric you should optimize, or what kind of corporate words here, KPI, key performance metric, whatever they want, it's kind of hard to define and make everybody happy. Or rather, it's really impossible to make everybody happy. That's just the business logic. And then you get into the mathematics. What kind of metric should I actually implement for my machine learning model? So that can take a while to think through. You can have customer satisfaction. You can optimize on revenue, and there's multiple definitions around that in most companies. What I suggest is just pick one and optimize on it. Because nobody really knows what the best metric is. But the reality is, when all those relevant metrics are relevant or good for your business, when you optimize on one, when you see an increase in your model, when you're making prediction, you wrote it up, look at the accuracy or whatever, if one of them is optimized or the metric is going up, all of them will simultaneously going up. In the initial stage of your machine learning project, I would say it is a waste of time trying to define the perfect metric. Pick one and start iterating so you can fail fast. One thing I've discovered, or I think a lot of people have seen, is machine learning project can fail because of the data. No matter how smart your team is, it can still fail just because you don't have the right data. So you can build a lot of good stuff. You can say, oh, you have this roadmap, we're going to optimize on this metric, it's going to bring the business X amount of dollars. That's great, but when you start working on it, it might just not work. However good your software engineering is, might just not work because you don't have enough data or your data is corrupted. But when you start working on it, try to just optimize on one of the metric and skip trying to argue about, oh, what's the perfect metric I'm trying to choose. That can come later when we know that this model will improve. If it doesn't improve at all, just go ahead and kill the project, go to the next one. Or maybe not exactly killing your project, maybe making some recommendation to the business owner and say, hey, maybe this type of data we don't have, but we know what type of problem we're trying to solve. So if we have this data, maybe we can come back and visit this problem. So in any case, pick a metric, stick to it. You can, optimize on one metric, stick to it in your project, but you can always monitor all the metrics that are interested at the same time. And if you want to go to use another metric later, that's totally fine. Pick a metric and optimize. Question 2, what kind of model do I use? Or how do I build my model? I think, to me at least, when I was starting out 2 years ago, I was in a little bit of analysis paralysis just because of the sheer amount of possible routes in building a model. If you look at the books, most books or online tutorial at least try to teach you 10 different algorithms. And it's really hard. It's really hard to pick a model, but I think just like building good software, you want to start small. What I meant by start small, I will go into in depth later. But in general, you don't want to start with the state-of-the-art model because state-of-the-art models usually takes a long time to train. That's given that you can find state-of-the-art model. A lot of real-world problems, just because of the business or industry they're in, you can find nothing on the internet. I would imagine it would be really hard, for example, to find insurance models on the internet because every company will try to protect it. Or retail models on the internet, no academic or academia, they just don't have access to retail data. You will see a lot of data on image, video, audio, kind of like things that we kind of understand what's going on even in a century or something like that. But there are a lot of things that has quote, quote, social component to it, and they evolve with our society. Those kind of data tend to have very little information online on how we get started. So I would say that the best strategy is start small. Build the simplest model you can get your hand on. Why? Because once you have a model ready, that's your baseline. You can use that to make more features. You can use that to understand your features. Remember, a simple model is usually low in complexity, so it will also help you understand your data. It takes less time to build. It takes less time to talk back and forth with your team about what kind of metric we should use. And also, if there's a problem in your data, a simple model is usually easier to debug than a complex one. We heard a lot about neural networks. So like one thing about a very common neural network architecture people use is, I think it's called VGG16 recently. It has over 100 million parameters. How do you even debug that for your business problem? If there's some problem with your data, one of the columns just all of a sudden become a null, or you realize, oh wait, there's a weird business logic change 2 years ago that nobody let me know. A complex model might pick it up or it might not. In any case, we won't be able to know. So you might want to start with a really simple baseline model. My go-to is logistic regression. That's one of the reasons why people say logistic regression rule the world, is because it's a simple model that everybody knows. If you're in the business of data, and it's easier to debug, it's easier to help you diagnose problems in your pipeline, and you can always iterate after you have that thing in place. And also, try everything. Personally, I really love kids because of their curiosity. I will go in depth in the next slide later, but I think the right question to ask wasn't what kind of model should I use, but rather how many models can I try in the same amount of time? And that really has to do with how good your data engineering or your software skill is, which I don't really have. So that was one of my biggest trips. One thing I learned was if you're good at software engineering, you're good at automating stuff, you can provide tons of value to the team. Tons of value, incredible value, because you can help them automate a lot of stuff. They can try all their ideas in a really short amount. Your data analyst or whoever you're working with, or yourself, you can try a lot of things at the same time, because like I said, a lot of the data problems nobody has ever done any research or public research on it in academia or elsewhere. So there's no reason why one model should work better than the other. And that question is really hard when you go between industries. Just like the model that people use on Kaggle might not work for your business just because you have different business logic. So you might want to make a laundry list of things or a backlog that you want to try, and just see how fast you can go through that list. One thing that's relevant to this question was something that people asked me 2 weeks ago was, if you're you don't have a background of building models, you have not started learning about all those fancy buzzwords of random forest, neural network, something architecture, deep learning, and so on. Where do I start? I would suggest that, well, I'm a mathematician myself, and I really don't think you need that much of mathematics to start learning about things. And we know everybody has limited time. It's just like no way you can learn everything. How do I pick the most efficient thing to learn? Start from trying things out on your problem. If you have 100 models that you can throw at it, because for some awesome APIs that you can call that can just automatically fit your data, just fit everything. And then pick the top 3. That's top 3 performers. And if you really want to understand the mathematics or the inner workings of those models, start from there. Then you don't really need, because there's just no way, and I think it's not practical for you or anyone to learn the 100 models and then just only after you're qualified for, I don't know, there's no certificate I'm going to give to you if you learn 100 models. So I'm being more practical in how we learn. I think it's better to learn things that would be used. So start from, because there are some really awesome APIs out there, Python, R, Scala, whatever, Java, I don't know. There are a lot of things out there. Just start from trying, build the models, start simple. Once you have one model, usually you can just swap that module. It's usually pretty modular. You can just swap it out. And just look at the ones that are doing better or the best ones for your problem. And then if you want to understand what's going on under the hood, go from there. I think that's a better way to try to capture what's going on in this field. But I will go deeper into why I think you should try everything into with some example of my things I've learned. So one thing I would say I fell victim or I'm guilty about was when I first started out. This is one thing I realized only 2 years later. that when I started out, I was kind of a purist. Pure in the sense that I think a good model is like a blender. Think of Smoothie King. I don't think there's a Smoothie King here, but if you drive into a Smoothie King, you just order, oh, I want an apple, kiwi, kale. Okay, we're gonna give you 32 ounce, and then you just like go and shop and just good, nice smoothie, and you just drink it. That's awesome, right? It's very convenient. That's what I used to think about the models. The models are like my blender, and my data are like my ingredients. You just throw everything into one blender, and boom, magic happens. I have this tasty smoothie I can use, and the business is healthy and strong. But then I started to realize that maybe it's not really like a blender. Maybe it's more like making good food, making cuisines. Why? I'm thinking about curry here, but I don't really make curry, so correct me if I'm wrong. There's really no way why this one blender should fit everything. If you're shopping for a blender, you have $30 blender, you have a $1,000 blender. What I used to think was, when I built my model, I'm kind of like picking one blender from my catalog. I just throw everything into that one blender, and hopefully something good will happen. But the reality is, most of the time, it wasn't the price of a blender that determines the quality of the smoothie, it was the ingredient. And another thing is, there was no reason why one blender should work with, why do I have to throw everything into only one blender? I will develop the thought a little further. Is when I first started, I read a lot of books. I did that laundry list of learning model thing, just read a book and learn all the models. And I think my brain has this thought of, oh, it has to be random forest versus boosted trees, or versus logistic regression. Sorry, if you don't understand, that's fine. Just names of the model, they're not really important here. But the context was because I think tutorials and online courses, they tend to split the methods by how they are constructed. And my brain kind of picked up on that idea. So like, oh, I have this one problem. I should use random forest to solve it. It didn't occur to me later, maybe what I should try is a combination of logistic regression and random forest. Kind of like when you prepare good food, sometimes some things go into the skillet, and some things you prepare next to it, you're boiling on the stove or something like that. They're going in parallel, and then you combine to make a really delicious dish. There's no reason why one model should work on all parts of your data. If you think about your data, a lot of the data we're dealing with have some important slices to it. Maybe it's your customer base, maybe their demographics. I'm thinking about baseball. I'm a huge baseball nerd, baseball fan. So if you're not a baseball fan, baseball has 9 defensive positions. You have pitcher, you have outfielders, infielders, catcher, and so on. There's no reason, even if I'm optimizing on batters or people who are trying to put the bat to the ball, why does a model have to work both in the infield and the outfield? There's no reason to it. And if you think about the strategy as some sort of divide and conquer, having less data or trying to fit a model to important slices of the data, it might save you some training time. And there's if you want to provide business value, you don't have to solve the whole problem to provide business value. If you can solve it on a small slice of your data, that's a great lead to buy you more time. And so now the way I think about how I should work on things is I start to drift away on, oh, I should try random forest on this data. I should try neural network on this data. But rather, I would probably start out with a slice of data that I understand better and build a really simple model to see if it performs. And then repeat the same process for other slices of data. Because there really is no reason to stick to one model. We're not in academia and we don't have to publish paper. I think one thing about why all the papers you read online, they always say, oh, our method beats other method. You will never see them do this kind of thing, what we call an ensemble method in a paper. Very rare. Or stacking models up. But if you go to industry talks, you will hear a lot of times that's the model they came up with. They usually don't have a roadmap and say, okay, this is the way I'm going to build this 5 different modular pieces into my model I'm using. No, it's a lot of times because they test it on different slices of data and they put it together and realize that's the best way to do it. But it won't work for professors because you don't want to borrow someone else's method because it won't give you a publication. But that was one of my problems is when I started out, I tend to say, oh, let me just try everything in random forest or in XGBoost. Actually, XGBoost was one of my first. I just throw everything and then I try to optimize the hell out of it. And now I think about it, it's a lot of wasted opportunities. Optimizing hyperparameter or parameters as in, you can think of it as the state in your model. That thing has almost never provided significant gain to my projects. What was almost always different ways to chop my data up, to make better features, to try different things that is not what I'm currently doing. Think like a baby. Just grab a rubber duck. If you don't like it, throw it away. Pick another toy. Another thing that happens a lot was garbage in, garbage out. Just like the blender, if you have a blender and your data is garbage, you throw it into the blender, you can still get a smoothie. And the crazy thing is, you have a very, very expensive blender, so you throw all the crap in it, you get a smoothie, and your business owner will drink happily. And when they drink it happily, it makes my imposter syndrome meter just go way up. Because I know it's probably crap. But they think it's all right. And I think most of us in the room, all of us in the room, are honest people. So we want to avoid that. I'll give you an example is baseball. Again, too many baseball references. Bear with me. It's juice ball. Juiced is a very, very negative connotation in baseball. If you're not watching baseball, juice means someone puts steroid into their body and be jacked. Not me. I'm not juiced. So if you watch Major League Baseball these days, you will see a lot of teams, if you watch the outfielders, especially if you're in the game, you will see that before each play, they will try to feel their pocket, okay? And they will take this small sheet of paper out, and they will just walk 3 steps, 5 steps to the right, and then stand there ready for defense. What's going on was there's analytics feeding into most of the Major League Baseball teams these days, and they're optimizing on their defensive positions to save the runs. So I would say most teams are really good at this kind of stuff these days. Before 2016, baseball has a really, really terrible run suppression problem. Suppression is in the games tend to be low in score compared to 2000 and stuff like that. That's before 2016. And then 2017 happened. No, you're fine. 2017, when teams started playing spring training in April, they found out, whoosh, balls start carry longer distances. What's going on? And people start speculating. 538, all the sports blogs. I'm not sure about ESPN, but most trustworthy sports sites start talking about these problems. So what happened? Why all of a sudden balls start carrying longer distances? And that would render your model kind of not in a good position. if you think about this type of thing, this is like kind of a garbage in, garbage out situation that will happen in the daily life. Because what we discovered this year, 2018, was Major League juiced the ball. Juiced as in they did something to the surface of the ball to reduce the drag of it last year, and they didn't let anybody know. So you saw a 35% increase in home runs. Pitchers are whining, but nobody knew why. Everybody observed this phenomena. This type of thing can happen in your business as well. Because all the business people like to change their logic because they think it's good for the company, creates tons of headaches to your data people. And what's the problem if you have a really, really complex model? You have to solve this issue. You have to redeploy something. If you don't have a baseline of a simple model or an ensemble of some simple models, each take care of just one part of your data, it can be really hard to fix this type of situation when there's a change in your data that's due to some unbroadcasted change in your business logic. And that happens all the time. All the time. There's just no way for someone sitting in the cube to know everything that's going on in the company or shift in the business. There's just no way. So if you start small, if you have a strong data pipeline, you have some tests around it. If you have a really simple baseline model that you can rely on or fall back to, you can fall back to your simple model and use that when you think about how to solve this type of problem. I think this is most likely just an analogy, but I've seen a lot of it, and I would say this is a tricky problem that nobody knows how to solve because you just cannot control the business. Most of the time I'm writing code, but I can be better prepared for it. And that's one thing I still haven't really figured out yet. So I would say help everyone figure out. If you have something to say, feel free to tweet about it. Let me know. I'm willing to discuss with you. The last thing I want to say, this is one thing I thought I came only 2 weeks ago, was there are some data that is simply hard to label. Hard to label. If you do image classification tutorials, a lot of time the first example will be how do you classify dogs from cats? Is that a dog or a cat? I don't know. If I drew it, I don't know what I drew. So I can't tell you if it's a dog or a cat. Maybe it's either. Maybe it's a mice. There are some data that are just natively hard to know what it is or hard for your model to predict. And one thing I've learned was if you're working in natural language processing or image, most companies will go through a stage of manual labeling. You will have to kind of like understand what you're doing with your data, so you have to kind of crowdsource it or just have like, I don't know, 100 people in your company each like do like 10 survey, like it's like kind of a little survey or whatever, just some way to increase the data or the amount of data that you can trust. But there will always be something that's hard to label, or when you had your first iteration of your model, you'll find that your model is not performing so well on it. I think it's the natural response for me, at least, is how can I build a model? It's kind of like I solved 80% of the problem. How can I solve this 20% that is left to solve better? But this iteration of how to deal with the hard to label data is something that may, when you're labeling data or when you're trying to understand data, just start with a column, just start collecting or label them. You can have two labels. If you're working on classification of text, you can have one column that says, oh, I want to, sorry, not text, I'm thinking about pictures. So this is a dog, this is a cat. And if you have something uncertain, just put it uncertain. And a lot of time you will revisit those uncertain ones. Those will be kind of like the baseline that we're trying to compete against, say, a human baseline. So those are things that you can think about when you're collecting data or when you're starting a project. Look at what are some edge cases. When I think about it, this is maybe true, maybe not, because I'm not very good at testing. But I would imagine software, you want to test those edge cases. This is kind of like the edge cases for your data. And it's good to label them ahead of time so you can revisit them as fast as you want to. But that's pretty much all. So like I said, if you took any picture, whatever, just feel free to let me know or discuss. And if you, back to the call to action, tweet COTP 2018. Let's put Jacksonville on the map, and let's help each other take notes. But you can reach me on Twitter if you have a question. You can find me on my blog, but that's pretty much about it. Question?
Yeah.
Yes.
You were making reference to a smaller model and also the ensemble learners.
Mm-hmm.
All things being equal, assuming we have a monolithic model that's taking a lot of parameters,
Mm-hmm.
and then an ensemble model, several small models.
Mm-hmm.
Would you say it would be better, assuming they're equal, I know there's a lot more to it, would you say it would be better to go ensemble or monolithic?
I would think ensemble is better because when you build ensemble, let me put it another way. There are different ways to build ensemble models. I'm thinking more about ensemble models that will tackle a specific subset of your data or just using less columns than your whole data. So you are not using all the features. It's kind of like you have all the features thrown against one model and trying to get the output versus having a bunch of smaller models that use less, 10% of the feature at a time. And if you have that and you have a problem with one of your feature or some bugs that you want to find out, it will be much easier to deal with that one small thing than trying to debug your monolith. So that's where I come from, and that's kind of why I think ensemble is a better approach now compared to where I started.
It's a good question. You mentioned your mathematician education,
Mm-hmm.
your mod work. Do you mainly use SAS, R, or Python, or some combination of that? Because where I work, we're a big SAS shop. We have 1,000 SAS programmers.
Right.
We probably have 240 R programmers. A lot of our data scientists switch on to Python and modeling. We also have this data robot that runs 24/7, 365 days a year. So you mentioned that your challenge is getting the data to you, right?
Right. Right.
So what is your software of choice for you?
So the question was, what is the software choice for solving this type of problem? It could be SAS, it could be R, it could be Python. But personally, I started out with R when I was learning and in my previous job. And these days I've been using more Python because it provides a better interaction with most programming languages. And also, a lot of times it depends on what kind of tech stack you're working with. So I think it's really the tool, and I think SAS is great. There's no reason to switch to it just for the sake of it. And I think that a lot of times it really revolves around how you want to solve the problem because they're really all tools. I think Michael mentioned that in the last talk too, that machine learning is a tool. Programming language is a tool. And really you don't need to pick the best tool to use it, just the right tool. Or close to right. Or just improvise based on what you have. Any other question? Okay, if not, I want to say that I don't know if there's anything like a Slack channel in Jacksonville or something. If there is, like about data people that I guys talk about, I'll be happy to advertise it for you. My friend has, when I was in Nashville, there's a Google group or a very active Slack channel called pennyuniversity.org. I learned a lot about those peers. The idea was, you get coffee with someone or just have a Google Hangout with someone and learn from them. There are a lot of brilliant data scientists there. So if you want to learn more about it, just go to that. Penny University. The idea was back in British, in Oxford, they had 1 penny for a coffee, and you invite someone to chat. So, but that's all. I will see you later. And feel free to find me in the hallway. I'll be wearing this shirt today, so it should be easy to see. And just look me up, Twitter, social network, come chat. I'll see you later.